So in this video, I'm going to be talking about infinite series and the connection between a sequence and a series, and really what we're going to be doing in our Calc 3 class for the next 3 weeks. So here we go. So that's some stuff written out here. This is an example of a sequence. We'll start out with the yellow here. So there's a sequence. Sequence is we've talked about this at the very beginning of class, but so this is just a reminder. Sequence is an ordered set of numbers that have a pattern to them. So in this case, you may have recognized the pattern right away. Of course, that little 2 at the end helps, but you start with 1, and then you multiply by 2, and then multiply by 2, and then multiply by 2. So any term in the sequence can be determined by 2 to the to a certain power. So in this case, it lines up nicely that the first term is 2 to the 0 power. The next term is 2 to the first power, and then 2 to the second power, 2 to the third power, etc. So you could say this is, this would be a sub 0, that would be a sub 1, that would be a sub 2, a sub 3, a sub 4, and of course a sub n. And so that's a sequence, and the sequence could go on infinitely, or we could stop at a certain point, I guess. And there's this that I've written here, 2 sub n. That's the explicit formula for this. A sub n is equal to 2 to the n. So that's the equation I can use to find the term, any term that in the sequence that I wanted to, by plugging in the right term number. So if I want to know what the 8th term is, that would be a sub 8. It would just be 2 to the 8th power. So that would enable me to find that term. Okay. So now a series, which is what we're really going to be focusing on, is, one other thing, notice the notation I use for sequence. This is what we'll be using consistently throughout this process for sequence. And we'll visit that again in a minute. So the thing that we're really focusing on in this class is series. So a series is you take a sequence and you add up all the terms of that sequence. So you can see this is a series that corresponds to the sequence that I wrote up above. So, and notice the notation. In this case, I have a sub n. There's nothing in front of it. Then I'm referring to the sequence. Down here, I have the sigma notation in front of it. So that's referring to series. So this is saying add up the terms of that sequence. And also we use a cap. That looks like an integral. It's supposed to be just a really big stretched out S. That's often what we use for series, and we put a little subscript here. If we want to sum up just the first 6, yeah, actually I did that wrong. If we're doing the first 6, that should be 0 there. So there'd be an extra one there. Okay, so the number down here is not telling me the number of terms, but telling me the term that I end with. So, so in this case, because my sequence started with a sub 0, again, remember sequences in series can start with a sub 1 or a sub 0. Those are the 2 usual places we start. So in other words, you're either starting with the initial term or the first term. And that, of course, just affects the way you write your formulas. But in this case, we start with the initial term. So notice in my sigma notation, I'm letting n run from 0 to 6. So this number tells me what number to plug in for n first. This tells me not how many things I've plugged in, but it tells me the last number I'm plugging in. So this says plug in 0, and then the indices in a sigma notation always go up by 1. So in this case, I'm going to plug in 0 for n, and then 1, and then 2, and then 3, and then 4, and then 5, and then 6, and then I stop after I plugged in 6. Notice that'll produce 7 terms, right? Even though the last term here. So this is not the number of terms I'm adding up. It's the n for the last term that I plugged in. So we converted the a sub n into the explicit formula that it is. So this is telling me to add up the first 7 terms of that sequence, because I start at n equals 0 and go up to 6. And this is what it would look like. 2 to the 0 power, 2 to the first power, 2 to the second power, 3rd, 4th, 5th, and 6th. And so you'd add those up, and that would give you the sum of that series. Okay? Now, because we just did a finite number of terms, this is called a partial sum. Because the other option, of course, is an infinite sum. And that's really what we're going to be dealing with is infinite series. So we're going to add up an infinite number of terms of a sequence, and then we're going to ask the question, does this sum diverge or converge? And notice we have to ask the question whether it's divergent or convergent because we are adding up an infinite number of infinite number of numbers. And so you can't really say what does it add up to. We're saying as we add up these numbers, are they getting forever big, or are they getting bigger and bigger, but converging on some number, meaning they'll never get above that? And just to give you a quick example, this is one of my favorite examples with series. We have a dog that's resting. It's a pretty dog. And just a foot away over here is a flea. And of course, as we all know, fleas like dogs, and they like to get in their skin and root in or whatever. So this flea is going to jump because he's so excited. He's going to jump with all his might towards the dog, and with all of his might, he's able to jump a total of half the distance. And remember, there's a foot in between here. So the flea was able to hop half a foot. So that was the first term in this series. So what we're going to do is we're going to use this as an example of a series where we're going to add up the hops of the flea to see if he ever gets to the dog. So his goal is to get to the dog, which is a foot away, right? So after that big hop, though, the flea lost some energy because it took a lot of energy to jump that far. So, but he's still excited about seeing the dog, so he's going to jump again. And this time, once again, he only clears half the distance. So this time he only jumped a fourth of a foot. And again, that tired him out, so he's not as powerful as he was, but he still is just as enthusiastic. So he gives us all of his strength and hops again. And this time, he only covers half the distance. So he just covered an eighth of a foot. And of course, if this process continues, that him leaping with full power and losing his energy, so he can only jump half as far the next time, then you could see that this would be 1/16 plus 1/32 plus 1/64, etc., etc., etc. Now, the question is he ever going to get to the dog? That's the question. So, and we can, without writing any formulas or anything like that, we can look at this and say, well, no, it doesn't look like he is going to get to the dog, does it? Because every time he hops, what we've noticed, the pattern is that he always covers half the remaining distance. And so even though he's jumping half a foot, a fourth of a foot, an eighth of a foot, a 16th of a foot, etc., if you add all those up, he's never going to quite get to the dog because there's always half the distance left before he jumps is still going to be left after he jumps. So he will never get there. So we would say, but he's going to get close, of course. He's going to get very close. So we would say that the sum of this sequence is converging. What is it converging? Is it ever going to get there? No. But it's going to get closer and closer to there. In fact, the more times the flea jumps, the closer he's going to get to the dog, or the more terms we add up, the closer we're going to get to 1. But it'll not ever actually reach to 1. So that's an example of an infinite series that we go on. Again, we're adding up an infinite number of numbers, but it's not going to get infinitely large on a finite number, and actually not a very big number. Okay, so that's really what the class is about, or the next 3 weeks of this class is about, of being able to figure out whether a infinite series is converging or diverging. And of course, we're going to get some very elaborate tests and so forth to determine that. But this just gives you an idea. Now, one thing just keep in mind, very, very important to understand the difference between this and this. This is sequence. This is a series. And be clear of what you're talking about, because you're going to be writing up some fairly lengthy answers to some of the questions we'll be asking. And so be really clear, because you're sometimes going to be talking about a sequence and you want to write this. Other times you'll be talking about this. So you can never say the series A sub n, because that's not a series. You could say the series associated with A sub n, but you might as well just say this, because that means a series associated with M. So that little sigma notation in front means add up the sequence terms, right? Okay, so I think I'll pause that. That's a good little introduction to the concept of infinite series.